Hi everyone, I am SS Kiran. I would like to discuss about short question and answers in rectifiers and filters. In this chapter, I have discussed these are all topics. Okay, these questions you may face at the time of interview. Now we will enter into a questions. Okay, now I will read some questions randomly. You can understand the strength of the questions. Okay, at the time of explanation part, I will explain each and every question with answer. Yes, a second one, define rectifier. Sixth one, draw the circuit diagram of HWR, means off wave rectifier. 14th one, define percentage regulation for rectifiers. Okay, then next page. 17th, derive an expression for TUF in bridge rectifier, very important. Then 20th, draw output waveforms of filters. Okay, 23rd, list the types of filters. Okay, now we will enter into the question with answers. Okay, right. What is the first question? Draw the basic rectifier setup block. Okay, now you can observe there are 4 blocks here. The first one is transformer. What it is called? Transformer. In rectifiers, generally we can use step down transformer. Okay, what is the use of transformer? To for purpose of the transformation. If you have the high voltage, then we can reduce that voltage by we can use the transformer, step down transformer. Now the second block is rectifier. What is second block? That is called rectifier. Okay, the third block is filter. Okay, the third block is filter. Okay, now the fourth block is voltage regulator. Okay, these 4 are connected like this. This is the basic rectifier setup block. Transformer is used for transformation. Then next, rectification, transformation, rectification, then filtration, okay, regulation. Okay, you can observe waveform also. This is some input sinusoidal wave, some decreasing the amplitude. After the rectification, you get like waveform like this. Okay, then after the filtration, you may get some ripple. Okay, after voltage regulator, some maintain some constant voltage. This is the answer for first question. Transformer is connected to rectifier, rectifier is connected to filter, filter is connected to voltage regulator. Yes, fine. What is second question? Define rectifier. What is second question? Define rectifier. Very simple. This is the circuit diagram of the rectifier. Some V input if it is AC or something. If it is input AC, here diode and seriously connected with resistor. Okay, what is the definition for rectifier? This is the circuit diagram. Okay, now we enter definition. A rectifier is a device. Okay, every transistor, everything, diode, everything, filter or everything is a devices or devices. A rectifier is a device which converts AC voltage into pulsating DC voltage using one or more PN junction diodes. The definition of rectifier, it simply converts AC to pulsating DC, which is using one or more PN junction diodes. Okay, that is the definition of the rectifier. Now define filter. Okay, this is filter. Filters are generally we can use capacitor filter, inductor filter, CL filter, LC filter, CLC filter. These are all the different types of the filters. Okay, this is circuit diagram. Now actually we get output at the rectifier side by rectifier output is connected to the filter. Now we enter into the definition. It is seen that the output of half wave or full wave or bridge circuit is not pure DC. Actually, what rectifier said? Rectifiers is converting AC to pulsating DC. Now coming to the filter definition, output of the half wave or full wave or bridge rectifier circuit is not pure DC because it's some pulsating DC. It contains fluctuations. What? It contains some fluctuations or some ripples which are undesirable. To minimize, to eliminate, whatever it is, to minimize these ripples, content in the output filter circuits are used. What is the use of filter? Whatever we get the ripples at the output side, to minimize the ripple content in the output filter circuits are used. These filter circuits connected between the rectifier to load. You can check here. This is some rectifier V in. We can feel rectifier. This is load. Between this rectifier and load, we have to connect this filter. So what is the exact definition of filter? Filter, it contains fluctuations of the output voltage to minimize or remove the ripples by using filter. Yes. Now fourth question. Define regulator. What is a regulator? It terms having some meaning. Regulates the voltage. Okay, definition. A voltage regulator is an electronic circuit that provides a stable or constant DC voltage independent to the load current. What regulator can do? It maintain constant voltage or stable voltage independent of the load current or temperature and AC line voltage variations. A voltage regulator, if you can use any circuit, output of that voltage circuit, it maintains constant DC voltage or stable voltage independent of the load current temperature. Okay, this is the definition of the regulator. Every time you can draw circuit diagrams also, right? Okay, next. Just see the diagram, how rectifier is connected to circuit. Okay, this is V input, some R. Now here rectifier is connected to reverse bias. Okay, this is the load resistance. Okay, this is the circuit diagram for the rectifier. Okay, this is circuit diagram for the rectifier. You can also observe the current equation. Input current IE is equal to IZ means GNR current, IL means load current. KCL law, sum of entering into this node and leaving this node. Okay, here IE is entered, this IZ, IL is leaved. That's why we can write here IA is equal to IZ plus IL. IZ means GNR current, IL means load current. Okay, this is the definition with circuit diagram of the regulator. Okay, now what is the difference between full wave rectifier and bridge rectifier? Okay, first you have to write the first difference. In full wave rectifier, we have to use 2 diodes with center tap transformer. In bridge rectifier, we have to use 4 diodes, any transformer. Okay, now coming to differences. It uses center tap transformer in full wave rectifier. It does not use center tap transformer. One diode conducts, very important, one diode conducts in each half cycle of input. Here coming to bridge rectifier, 2 diodes conducted in each half cycle of the input. If you understand, if you can see the diagram, you can understand the how it will be conducts. Okay, the third point, the voltage drop across the diode is due to RF only. The very nice point. Voltage drop across due to RF only. Okay. The voltage drop across the diode is due to 2RF. Right. Very good. The TUF. Transformer utilization factor 0.693. Here 0.812 for bridge rectifier. What about PIE? PIV, peak inverse voltage. The diode full wave rectifier is 2Vm. Coming to bridge rectifier, that is called Vm. Okay, good. Now we will enter into a sixth question. Draw the circuit diagram of the half wave rectifier. Actually, what is our basic concept in this basic rectifier circuit? First, we have to use transformer, then rectifier, then filter, then voltage regulator. Finally, you have to draw load also. Okay, for understanding. Okay, first you have to draw transformer. This is the transformer. Step down transformer. Input is 230 volts. Output Vm may get 12, 6, 18 based on the transformer specifications. Okay. Now again, what we have to connect here? Rectifier. After the transformer, you have to connect what? Rectifier. This is one diode can be act as a rectifier. Then one RL, load resistor. This is the circuit diagram of the half wave rectifier. What is the operation? It conducts only positive half cycle. What about half wave rectifier? It conducts only positive half cycle. Then obviously, what about second quotation? It does not conduct negative half cycle. Okay, this is the circuit diagram of the half wave rectifier. Yes, now draw the circuit diagram of the full wave rectifier. In full wave rectifier, and compulsory you have to choose an center tap transformer or center tap step down transformer. Okay, in this transformer you have to, in this full wave rectifier, you have to use two diodes. One is D1 and second one is D2. You know the operation. In positive peak, D1 is conducts. Negative peak, D2 starts the conduction. Very simple. Transformer. This is called transformer. First block. Second block rectifier. And final last ending block load resistor. That is equal to RL. This is the circuit diagram of the full wave rectifier. How we can draw? These two diodes cathode terminals are connected. Center tapped middle wire is connected to load. Whatever we have connected this cathode block, whatever we have connected cathode point is again connected to other end of the resistor. Okay. Now, eighth one. Draw the circuit diagram of the bridge rectifier. Same phenomena. First you have to take transformer, then you can take rectifier, then you can take what? Load resistor. Okay, these four diodes can be connected as a bridge because of this is a bridge rectifier. You know very well the bridge just you can observe the diagram. Okay, all cathodes or all anodes facing one side. Just you can see, you can observe these all cathodes are facing one side. Okay, that is called D1, D2, D3, D4. One, if you can do practice, you can understand how we can draw this bridge rectifier circuit. Okay, the bridge rectifier circuits, okay, circuit is essentially a full wave rectifier circuit using four diodes. Bridge rectifier circuit is also called full wave circuit, full wave rectifier. Okay, forming the four arms of an electrical bridge. It's forming an four arms of the electrical bridge. What we can do, one more point, transformer having two windings. This is primary winding and this is secondary winding. Primary winding, you have to connect phase and neutral of our power supply. Secondary terminal, whatever we have the joint of anode and cathode, that joint point is connected to phase. Here same, anode and cathode junction, you have to connect another terminal of another wire of the transformer. Remaining two terminals, this joint and one more, this joint is connected to load. Okay, right. This is the circuit diagram of the bridge rectifier. Now the ninth one, derive equation for IDC and IRMS for full wave rectifier. I mean, you here only I asked derivation. No need to worry about total explanation part. Just you can concentrate full wave rectifier. You can see what is the output of the full wave rectifier. This is the full wave rectifier output. Yes, you can see in this full wave rectifier, what is the time period? 0 to pi. Okay, so again pi starts the waveform. Okay, now in full wave rectifier, the time period is pi. Now you can concentrate what is the time period? Pi. Coming to half wave rectifier, what is the time period? Again the wave starts from 2 pi. That's why in half wave rectifier, the time period is 2 pi. Coming to full wave rectifier, the time period is pi. Not here, here. The time period is pi. Okay. Now we will enter into the derivation part. Okay. First of all, I will concentrate IDC. IDC means it's a current. IDC current. Okay. IDC we may also called as a average current. What is the equation for average current? Very simple. 1 by time period integral lower limit to upper limit with some function with respect IL, with some function. Okay, that is called IL, and d of omega t. This is our basic function. That is nothing but the average. IDC current is also called average current. Okay. Now, what is IL? Already I have explained. It looks like a sine wave. This is this is sine wave, sinusoidal wave. That's why if you can take Vm, simply you can write Vm sine of omega t. If its amplitude can be treated as a Im, you can write Im sine omega t. That's why here I can write Im sine omega t. This is the function of the IL of d. Okay. Now what is the equation here? 1 by time period 0 to pi integration 0 to pi. What is the function? Im sin omega t d omega t. Now do integration part, sin omega t integration minus cos omega t. Then substitute lower limit and upper limit. Do some integration part, and finally you get the IDC value is equal to 2 Im by pi. Oh, that is average current or IDC for what? For full wave rectifier. For what is FWR? Full wave rectifier. Now we enter into the IRMS. What IRMS? What RMS stands? R means root, M means mean, S means square. Now we can observe. You can see this equation, you can understand why I have write like this. Just you can check. R means root. What is root? Here root. This is the root. Okay, this is the root. What about mean? What about mean? You know, mean also we can call it as average. So that is called 1 by time period 0 to t integral 0 to t some x of t. What about square? This is nothing but square. That's why here I can write the square. Okay, this is the root mean square. How we write the function? Very simple. IRMS is equal to root time period 1 by time period 0 to 2 pi IL square d omega t. Actually here I can take what full wave rectifier. So simply you can write 0 to pi integral 0 to pi 1 by pi 0 to pi, because the time period is equal to pi. Okay, otherwise you can split into 0 to pi plus 0 to pi. Finally you get the answer. IRMS is equal to Im by root 2. Do some derivation part, you get like this. Yes, good. Okay, one more, just you can observe one more circuit diagram, one more waveform here, that is called graph. This is a peak voltage, then at Vm by root 2, that is called RMS voltage, or Im by root 2. Okay, good. 10th one. Derive equation for VDC and VRMS of full wave rectifier. Very simple. Already I have discussed IDC. What is value of IDC? 2Im by pi. Simply substitute that value. Actually, what is V? V is equal to IR. What about VDC? IDC into RL. What about IDC? 2Im by pi. Substitute this value in this equation. Now how it will be convert? 2Im by pi into RL. Now what about Vm? Vm is equal to Im into RL. Now substitute Im RL replace with Vm. Finally you get VDC is equal to 2Vm by pi. Same. What about VRMS? Same phenomena. IRMS into RL. Im by root 2 into RL. What about Im into RL? Is equal to Vm. So finally VRMS is equal to Vm by root 2. So coming to full wave rectifier, IDC or I average current is equal to 2Im by pi. IRMS Im by 2. VDC 2Vm by pi. VRMS Vm by 2. What about, this is full wave rectifier, fine. What about half wave rectifier? Very simple. Im by pi for average current, Im by 2 for RMS, IRMS, Vm by pi for VDC, Vm by 2. These are all for half wave rectifiers. Okay, now 11th one. Write expression for rectifier efficiency. Very good one. Write expression for rectifier efficiency. The rectifier efficiency is defined as DC output power to AC input power. Very simple ma. PDC by PAC. What is the expression for efficiency? Efficiency is equal to PDC by PAC. PDC means power of DC output power. PAC means AC input power. Yes. Now final one. With respect to rectifiers, define VRMS, define IRMS, define PIV and TUF. Okay. These are all the some definitions. Okay. First VRMS. What about VRMS? VRMS is equal to IRMS into RL is equal to Im by root 2 into RL. There is no separate definition for VRMS. It can be treated as a root mean square voltage value. Now you can write this one. This is the RMS voltage of given sine waveform. Simply draw that waveform, then you can understand. Okay. What about IRMS? Same. IRMS is equal to Im by root 2. Already I have discussed previous question. Okay. Now what about PIV? PIV is nothing but stands before first stands for maximum peak inverse voltage. Common definition: maximum reverse bias voltage that can be applied across the diode before the operating to the Zener or breakdown regions. That is nothing but the PIV. Yes. Next, TUF. TUF stands for the transformer utilization factor. Okay. TUF is defined as maximum DC power delivered to the AC power rating of a transformer. Very simple. DC power is almost we can observe at the place of load. That's why we can call DC power delivered to the load. AC power rating of the transformer. That's why we can take AC power rating of transformer means it's input AC. Okay. TF means DC power delivered to the load by AC power rating of transformer. These three are the definitions of the some PIV, TF, and these are all. Okay. Next class or next video I will discuss remaining questions also. Okay. Thank you so much.